Let's look at another case of missing parallax that can break the camera solve. Here we won't have reference frames, no measurements, no extra data, but we still need to track the camera. I shot this one earlier. I'll set the camera parameters right away since I know them. The camera sensor size here is 23.76 millimeters and focal length 50 millimeters. Let's take a look at the shot itself. What can we say about this shot? It can easily be divided into 3 phases. The first phase, before the quick camera turn. The second, the turn itself. And the third, the final part of the shot after the turn. Why do we need to split it instead of tracking everything at once? Because in the first part we do have parallax. Background, foreground, midground. All of this shifts relative to each other. In the middle phase there's no parallax at all. The operator is just standing still and rotating the camera. And at the end, the parallax appears again. Let's start with the simple approach. Try tracking this shot as usual, without splitting it into phases. We'll hit the error, see how it shows up, and then continue tracking the shot the correct way. First, we just create trackers as usual. That's what happens when you start tracking without carefully checking the areas you're about to latch onto. We track as long as the point stays in frame. When strong blur appears, we can try expanding the pattern search range so the tracker doesn't lose the area where it should look for the match. And the blur tracks better now, because even a blurred image still forms a consistent enough pattern. We can tweak the image controls and boost the contrast a bit so the pattern stands out more and the tracker stays more stable. Let's place a point on the tree. We also need roughly 6 points, same as in any other case. So what can we latch onto here besides the trees in the background? We still need points on different planes, not only on the far background, but we'll see what we can find. The person in the foreground blocks way too much. Alright, we stop here and look for anything else we can grab onto. But honestly, there are very few usable areas in this shot. Again, we look for what shows the strongest parallax. I take this point. You can see it clearly shifts relative to the background, relative to the more distant forest. So we take it. When the pattern drifts, we correct it. And something else. Alright, let's make this one a long track, for example. The hand covers it. We can track a few more frames. Wait until the hand leaves the frame. And continue it. We check whether we're in the same spot. Not quite. We need to move a bit higher. Again, when the blur kicks in, you can increase the pattern size, but if there's almost no parallax in the background, it can start to get confused. So here you really have to watch closely how the point tracks in this kind of blur. So far, it's fine. Let's say we stop here. Beyond this point, it no longer reads. What can we do? At this moment, all the trackers we created earlier suddenly leave the frame, so of course the solver will freak out. But what can we do? Let's continue. Let's take this area. For the first, track forward. And I don't think we'll be able to track this same point backward anymore. Alright, let's grab this spot instead and track it forward as well. and few frames backward. Of course, during the turn there's no parallax at all, the plate just rotates, and we don't see the foreground and background shifting relative to each other. Let's add one more point and try solving up to frame 37 to see what we get. Maybe I'll grab this forest, it's far away. The pattern turns out huge, a very bold size, but let's keep it. No. Backward. Well, for this frame, we can add one more point. For example, this little hill. It's fairly contrasty, and it's clearly visible in this range. We can use a wider pattern so it holds more confidently. So it seems we already have enough trackers to solve up to frame 38. Let's try it. I open the sequence settings, enable frame range, and set it to solve from frame 1 to frame 38. And here's what we get. Only a few frames were solved. 1, 2, 3, 4, 5, 6. Let's see where they are, roughly in this range. That's because the program automatically chose the root frame right here. Let's see what happens if we change the root frame ourselves. For example, here we have 6 trackers. 1, 2, 3, 4, 5, 6. Well, let's assume this isn't the confident range. It looks strange. Yes, here the parallax becomes a bit more noticeable because the camera begins a big movement, but it's still not the best section. Let's set the root frame manually. We'll say our working range is from frame 1 to frame 38, and the root interval, where we have 6 stable trackers, is from frame 1 to frame 15. We go to the point group settings and turn off automatic root frame detection. And we set the root frames manually. On the first frame, menu, special frames, set root frame A, then we go to frame 15, where all 6 required trackers are still present, and set root frame B. Calculate. So now we have more frames solved. There are gaps, but we'll deal with them. Right now this range is solved, and this is exactly the case where manually setting the root frames helped. At this stage it works better. Later we might switch back to automatic mode. What we can see is this. As long as a tracker stays in frame long enough, the camera motion looks normal. But the moment new trackers appear and the old ones leave, everything turns into a mess. The horizon immediately starts drifting. By the way, I'm not even sure the camera actually solved. What we're seeing is something was solved, but not much. Let's track a few more frames forward. Because almost all the points we tracked suddenly cut off and new ones appear instead. 3DE simply cannot solve this. If points change gradually, the software has a backbone, a base of points it can rely on, and new points replace the old ones one by one. Here, all the points disappear at once. In just a couple of frames, everything we tracked is gone and completely different patterns appear, so there's basically nothing to solve. We see the same effect. Here, we still have some kind of solve, and then, where the average error drops to 0, that means it didn't calculate anything at all. Here it's just interpolating the motion. After this it will break off and stop tracking. So what do we do in this case? We need to split this move into several phases, because from here on, every 3 frames the patterns are completely replaced and the camera simply can't be solved. The result will be the same as before. If we don't set the root frames manually, it'll pick a few frames, treat them as a panorama, and that's it. It won't solve the rest. If we do set the root frames ourselves, it will only solve the section up until the trackers disappear in that hard cut, and beyond that, there'll be no solution. Let's see what range we can use to limit the first phase of the move. Ideally, we'd extend it to about this moment, but that might not work. Most likely we'll have to stop somewhere around here. Let's try setting it to 32 frames and resolving, and see if that helps. Alright, so we have motion up to frame 31. The first frame is solved too, frame 32 is not. Great. We can set this range here, turn automatic root frame detection back on. With this range and this motion, 3DE will handle it and resolve. And here we have our camera move. Here we can reattach to the neighboring tree since the helmet gets in the way completely. That's fine. It's the same tree, the same plane. It'll do. Let's calculate. And this tracker ended up where it should be. I think that's enough for this phase and for this example. What's next? With this set of trackers, the phase from frame 1 to frame 31 is solved. Let's separate them from the rest, because in the transition areas, we'll likely get small conflicts. We create a new point set. A point set is used to organize the project structure. Basically, it works like a folder inside the point group. We can create a point set and name it phase 1. And move all the trackers we created for this phase into it. We select them and drag them in with the middle mouse button. Now, when we start creating points for the second phase, the trackers from the first phase won't get in the way. We disable them. Let's open the curve editor so we can see which sections of the shot already have a solved camera and which ones still don't. Config, horizontal panel, curve editor. If we expand the 3D rotation position curves, we can see that there's an actual solve only from frame 1 to frame 31. After that, the curve continues, but that's pure interpolation. Where the error shows as 0, that's a sign this section wasn't solved at all. Same with position. There's real motion only in this range, and after that it's interpolation. And it immediately looks wrong, because there's no such camera move in the shot. So let's define the boundaries of the second phase. We already know where it starts. After frame 31, the trackers from the first phase no longer hold, so the next phase begins at frame 31. Where does it end? Let's roughly take it up to frame 56. We set the frame range calculation to solve from frame 31 to frame 56, and for convenience we highlight this range on the timeline. We've marked the frame range we're going to solve next. After enabling frame range calculation and setting the start and end frames, nothing outside this range will be touched during further solves. So, the camera is already solved from frame 1 to frame 31. Here are its curves. They will remain untouched. Only the section from frame 31 to frame 56 will be solved. And when we finish this phase and move on to the next, the previously solved sections will also stay unchanged during the new solves. So essentially, we're going to make 3 separate solves. The first one is done. Now we move on to the second. There will be no parallax here, no reference photos, and even latching onto the trees would be difficult. We only have what we have. So this is exactly the case where we switch the camera to fixed camera position constraint and gradually solve this range. Since we've specified that the camera motion is limited to rotation only, this type of solve needs just 1 or 2 trackers per frame, anywhere they stay visible. We've disabled everything from the first phase. And to keep things clean, we can simply hide those trackers so they don't get in the way. If we leave them visible, it won't be entirely correct for this type of camera movement, because for example on this segment, the trackers still show a bit of parallax relative to each other. And even if there is some parallax here, since we've specified this motion type, it's better to choose areas where there's no parallax at all. Let's see what we can latch onto. But I think we can start roughly from here. This movement is very smeary, so we need to set a wider search area. Now we're really going to see some heavy motion blur, but overall it's fine. We've got 1 tracker. Then we move to the frame where this tracker disappears and latch onto the other side of the frame. Well, let's say we take the next tracker from here. Something broke. Alright, here's the spot. Let's try pressing a line to key. Something like that. I like to key again. Let's try again. Then let's go here. We should probably adjust the image. Well, here it already drifts a little. Alright, the main goal is to reach frame 56. I'll switch the tracker so it actually exists beyond the frame edge, because if I create a new tracker on frame 56, it won't be nearly as useful for us. Let's solve. And here comes the turn. But it didn't get solved everywhere. We can see that it still exists at this point. I'm checking by the curve. Let's add more trackers. I think somewhere around here we can latch onto it. And also track it backward. So we'll be solving from time to time and checking what result we're getting. Here at the beginning we have 0 error, so we'll add trackers right here. Right now we have only one here. That's not enough. I'll run this tracker through a couple more frames, then switch to the area on the left, because everything is blocked right now. Ideally the trackers should be spread out evenly. At the moment they're all concentrated in one part of the frame. And from here, we'll run this point through, up to frame 31, up to our starting frame for this range. We can track it further, but there's no point. That's our starting frame. Let's solve it again. At the beginning, we no longer have 0 error anywhere. We move to the section where the camera is still unsolved. Here we have 3 trackers. The camera solves. Here there's only one, and the solve disappears. We move to the point where the number of trackers becomes low again. We extended the solve a bit further. Alright, let's keep going. Solve it again. We're adding literally one frame at a time, but the important thing is that it's working. Everything is progressing as planned. Alright, we're getting close to finishing this. So, it all really comes down to the pattern. If something clearly refuses to track, change the approach, search area, pattern shape, scale, try something else. Frame 56. We could keep tracking further, but there's no point anymore. Let's solve again. And it looks like we've solved our entire range. The way the horizon shifts now isn't exactly correct, of course, because we completely ignored parallax here. But at least we've locked onto the sky and there are no sudden jumps. We'll fix everything else later. Now we just have to solve the third range from frame 56 to frame 131. I'll create a point set for the second phase. And move all these trackers into it. I'll disable them. I don't need them for now. I set the next range from frame 56 to frame 131. By the way, because there is some parallax in that section, the error immediately goes up. It's noticeably higher than in the part we solved properly. Alright, let's track the final section. Somewhere around here it fell apart. Let's correct it. And track it to the end. Great. Here it's actually much easier to latch onto something. Alright, third tracker. Again, we need to pick points at different distances from the camera. This one has the most noticeable contrast relative to the others, of course, but I think we'll still find a few more good options. Here, for example. And we need one more tracker. For example, right here. Alright, and before we run the solve, by the way, we could have used the sky as well, we need to disable the fixed camera position constraint. No constraint, and we solve. A couple of frames drop out of the solve, looks like frame 56 in particular, but aside from that, everything looks pretty close to correct. Yeah, this is exactly the spot where it flies off. Actually, we can do a lens adjust here. A little changes. From 0 to, I don't know, maybe 0 to 2. I think not more than that. Solve it. Here we go. Everything looks pretty clean. So we've tracked 3 ranges, and essentially each of them is solved independently from the others. So here's the camera position in the first range, in the second, and in the third. These are different camera positions, different scales, and we need to stitch all of them together. How can we do that? Since we don't have any reference photos or measurements here, we can at least roughly set the scale using constraints. Obviously only by eye. For example, we have these 2 points. We can set an approximate distance between them by eye. I don't know, let's say around 50 meters. I have these 2 points selected. Constraint, create distance constraint. 50 meters, too much, right? Let's say 25. What kind of distances could we have here? What kind of distances could we have here? And move the trackers there. For now I don't need them, so I'll disable them. And switch back to the first phase. I'll set the range again from frame 1 to frame 31. I'll enable the trackers and solve the camera. Alright, here we can also set some kind of scale. Let's say these 2 trackers are 5 meters apart. That's what I want. Constraint, create distance constraint. 5 meters. Great. And in the second phase, in the second range, there's no point setting a scale because that part is just rotation. There's no depth. So here we have a good starting point. Everything looks fine. How do we attach the next range to this one? Frame 31 is the last frame of the first phase and the first frame of the second phase. The moment we switch to the second phase and solve it, frame 31 will be recalculated, but we need the next phase to start exactly from the camera position of the last frame of phase 1. To do that, we can save the camera position on this frame while it's solved correctly, and then restore it afterward. Those 3 buttons are for that. Stop pose. A red marker appears. That means we saved the camera position on this frame. So even if we move or rotate the camera now, we can restore the saved pose. Everything was fine. And in this frame we change the camera keys, we can press recall pose and the saved value will come back. So once again, store pose saves the current position. Recall pose restores the saved one. Even if we resolve the camera and it changes, we can still press recall and bring this position back. So once again, store pose saves the current position. Recall pose restores the saved one. Even if we resolve the camera and it changes, we can still press recall and bring this position back. We set the frame range from 31 to 56. We turn fixed camera position constraint back on. It matches the type of camera movement in the second phase, and we can disable the trackers that don't belong to this phase. And enable the trackers of the second phase. And we solve the camera in this range. So here we can see everything is solved. But from the camera motion curves, it's clear that the camera of the second phase was solved separately from the camera of the first phase, just like before. What can we do? How do we attach the second phase's camera animation to the end of the first phase? If we just press recall pose, we restore the camera only in a single frame. Now there's a seam between phase 1 and phase 2, but it applies only to that one frame. Let's solve again. And we'll do it a bit differently. 3DEqualizer has a built-in script called transposes. What does it do? It shifts the camera or object animation in the current range so that it matches the saved pose, or several saved poses. If there's one pose, it simply snaps the whole animation to it. If there are several, it distributes and stitches the motion between them. Here we have one saved pose, we select it, the pose saved on frame 31, and press transform. The script attached the motion in the second phase to the pose saved at the end of the first phase. If we look at the animation curve now, we'll see that it's smooth. Now you can clearly see the horizon drifting. That's because in this phase, the camera was tracked imprecisely. We were just sticking to the sky. We can fix this animation. Select all X keys and delete them. And for Z, to remove this rotation. We save the camera position on the current frame. We've already stitched the first two ranges and now we'll attach the third. In 3D orientation, you can see the camera at the start of the shot, then the turn, and the third phase is elsewhere. We need to attach it to the first two phases. So, in lineup we've saved the position. We set the range from frame 56 to 131. Turned off constraint. We disabled the trackers from the second phase and enabled the trackers for the third phase. Calculation. Now we attach this phase of motion to the end of the second one in the same way. Transposes, select frame 56 and press transform. And we get a single continuous motion. We can tweak the horizon a bit more. In this phase, the horizon line doesn't match reality. To fix this, we can go back to the second range and adjust the key positions to straighten the horizon. We disable the third phase trackers and enable the second phase trackers. We keep toggling them on and off because they might overlap in some areas and get in the way. If they don't overlap, you don't need to do this. Same here, from frame 31 to 56. And let's immediately set the horizon to the correct position. We can do it almost manually, right here on the graph. So we align the horizon to be level. We save this position now. And in the same way, we solve the third phase and attach it to the end of the second. We disable the second phase trackers and enable the third phase trackers. We remove the camera constraint. We set the range from frame 56 to 131. Recalculate. And we attach it to the saved pose. That's basically it. This is how we stitch the camera together from 3 separately solved phases. Overall, it's a pretty practical and real-world approach. Quite often you'll encounter complex shots that simply can't be solved in a single pass. In those cases, this is often the only way to handle such shots. And that's it. See you next time.